Hello everyone, this is Ganesha B and studying in Sri Venkateswara College of Engineering, and today we will be learning about implementation and demonstrations of Q learning. What is Q learning? Q learning is a value-based reinforcement learning algorithm uses Q values to iteratively improve the behavior of a learning agent. Goal is to maximize the Q value to find the optimal action selection policy. The Q table helps to find the best action for each state and maximize the expected reward. Q values or Q actions are defined for states and actions. Q the whole of S, comma A denotes an estimation of an action A at the state S. This estimation of Q will be iteratively computed using the TD update rule. Reward. At every transition, the agent observes a reward for every action from the environment and then transits to another state. Episode. If at any point of time the agent ends up in one of the terminating states, that is, there are no further transition possible, is called as the completion of an episode. Initially, agent explore the environment and update the queue table. When the queue table is ready, the agent will start to exploit the environment and taking better action. It is an off policy control algorithm, that is, the updated policy is different from the behavior policy. It estimates the reward for future action and appends a value to the new state without any greedy policy. Temporal difference of TD update. Estimate the value of Q is applied at every step of the agent's interaction with the environment. Advantage converges to an optimal policy in both deterministic and non deterministic MDPs. Disadvantage is that suitable for small problems. Understanding the queue learning. Building environment contains 5 rooms that are connected with doors. Each room is numbered from 0 to 4. The building outside is numbered as 5. Doors from 1 to 4 leads to the building outside 5. Problem. Agent can place at any one of the rooms 0, 1, 2, 3, 4. Agent's goal is to reach the building outside room 5. Represent the room in the graph. Room number is the state and door is the edge, as you see over here. Assign the reward value to each door. The doors lead immediately to target is assigned an instant reward of 100. Other doors not directly connected to the target room have zero reward. For examples, those are two-way. 0 leads to 4 and 4 leads to 0. Two edges are assigned to each room. Each edge contains an instant reward value. Let's consider agent starts from state S, which is room 2. Agent's movement from one state to another state is action A. Agents is traversing from state 2 to state 5. Initial state is equal to current state, that is state 2. Transition state 2 gives state 3. Transition state 3 gives state of 2, comma 1, comma 4, and state 4 gives state 5 as seen here below. Prepare reward table R of matrix. -1 denotes the no edge between the states and 0 represents the indirect edge to the target, as you see over here. Understanding the Q learning, prepare matrix Q. Matrix Q is the memory of the agent in which learned information from experience is stored. Row denotes the current state of the agent. Column denotes the possible actions leading to the next state. Compute Q matrix. Q state of action is equal to R state of action plus gamma into max Q of next state of all actions. Gamma is discounting factor for future rewards. Its range is 0 to 1. That is, 0 is lesser than gamma, which is lesser than 1. Future rewards are less valuable than current rewards, so they must be discounted. If gamma is closer to 0, the agent will tend to consider only the immediate rewards. If gamma is closer to 1, the agent will tend to consider only future rewards with higher edge weights. Q learning algorithm set the gamma parameter, set environment rewards in matrix R, initialize matrix Q as 0, select random initial source state, set initial state as is equal to current state, select one action A among all possible actions using exploratory policy. Take this possible action A going to the next state S, observe reward R. Get maximum Q value to go to the next state based on all possible actions. Compute q state of action is equal to r state and action plus of max gamma into max q of next state comma all actions. Repeat the above step until reach the goal state, that is current state is equal to goal state. So as seen in this matrix Q, set the gamma value is equal to zero point 0.8, initialize the matrix Q to 0 matrix. From state 1, agent can go to either state 3 or 5. Let's choose 5. From 5, compute max Q value to go to the next state based on all possible actions. Again, the same formula is applied, and then Q of 1 comma 5 is equal to R of 1 comma 5 plus zero point 0.8 into max of Q of 5 comma 1 comma Q of 5 comma 4 comma Q of 5 comma 5, as we see over here, and we get the solution as and the answer as 100. Then we update the matrix Q. For next episode, choose next state 3 randomly, that becomes current state. State 3 contains 3 choices, that is state 1, 2 or 4. Let's choose state 1. Compute max Q value to go to the next state based on all possible actions. Again, the same formula is used, Q state of action formula. And then we get the answer as 80. Update the Q matrix again. For the next episode, again, next state 1 becomes current state. Repeat the inner loop. U2 1 is not target state. From state 1, either can go to the 3 or 5. Let's choose the state as 5, compute max Q value to go to the next state based on all possible actions. And again, the Q state action formula is used, and the answer we find is 100. Again, Q remaining the same due to Q of 1 comma 5 is already fed into the agent. Now stop the process. So this is the end of the PPT. Thank you everyone.